information provided to write the standard form equation of each ellipse. Okay, the standard form equation for an ellipse is x squared over a squared plus y squared over b squared equals 1. Now, sometimes it may be x minus h squared plus y minus k squared instead, and let's talk about y. See how the center for this ellipse is at 0, 0? Well, if the center had been moved off, like say the center was over here at 2, 0, then you would show that by doing x minus 2. Or if the center was at 2, 1, it would be x minus 2, y minus 1. Okay, but for this scenario with problem 16, the center is at 0, 0. Alright, now we have to fill in something for A and B. Is this considered a horizontal ellipse or a vertical ellipse? Horizontal, because it's wider than it is tall. Okay, so how far is it from the center to the side? 5 units. So A would be 5. How far is it from the center up? 3 units. So now when I plug those in, what does the A squared become? 25. What does B squared become? Okay, if you plug in B and you square it, you get a 9. So that is the answer. That is the equation for this ellipse. Okay, now let's look at number 17. Okay, is this ellipse horizontal or vertical? Horizontal, but this time the center is no longer at the origin, correct? It's at 1, negative 1. So when you write the equation this time, you're not just going to have an x squared and a y squared. You're going to have to show that it went right 1, so minus 1, and down 1, so plus 1. Okay, now, since it's horizontal, that means the bigger number will be under the x. How far from the center to the side is it? How many units? Guys, from here, 1, 2, 3. Look, watch me count it out. Here's the center. So if I'm going to the side, right. But if you look at the numbers, 1, 2, 3, 4. So I have to move 1, 2, 3 units. Well, when you plug that in, remember it's a squared, so that becomes a 9. Okay, then from the center up is how many units? 2, so 2 squared is 4. Okay, number 18. Sketch the graph. This one looks very similar to the equations that we just did, but what's the difference? Remember in the previous two problems, both of them had a plus sign in the middle, right? Those were ellipses. This has a minus sign in the middle because it's a hyperbola. Okay? Now, you can have vertical hyperbolas or horizontal hyperbolas. If x is first, it is a horizontal hyperbola. Okay, so this would be horizontal. If y is first in the equation, that is a vertical hyperbola. Okay, when it's a horizontal hyperbola, it's going to open to the right and to the left. When it's a vertical hyperbola, it's going to open up and down. Okay, but before you can figure out where it's going to be on the graph, you have to look over here to see the shifts. What does x plus 3 mean? What kind of shift is that? Well, x plus 3 is actually left 3, correct. And then is there a vertical shift? No, so we're just going to go left 3. Okay, now under each of these is a 4. So originally the a value was 2 because it wasn't squared to become that 4. And so was the b value. It was also a 2. So what that means is you're going to go 2 units away from that first point you plotted, and that's going to give us our box. Now, what kind of hyperbola is this? Horizontal or vertical? Horizontal. No, this is a hyperbola. There's a minus in the middle. Ellipses have a plus sign in the middle. Okay, so it's horizontal, so it would look like this. They were always drawn on there for you on the worksheet. No, it would have had to have had a plus sign in there to draw an ellipse. Okay, it wouldn't have been a circle to begin with. We never graphed any circles. You did that in geometry, but not here. Okay, so I want you to try number 19. Okay, so we know this is a vertical hyperbola, and the reason we know it's vertical is because the y is first in the equation. The reason I know it's a hyperbola is because this is the equation for a hyperbola. Okay, it has a minus in the middle. Now, where do we start? 0, 0, because the y and the x didn't have anything with them. They're just y squared and x squared. Below the y is a 25. So what was the a value? 5. Okay, and since that's under the y, on the y-axis we go up 5 and down 5. Under the x is a 1. Think about it. If it were a 0, the whole thing would be undefined. And so b equals 1. So on the x-axis we go right 1 and left 1. Okay? Sorry, not my best box. Okay, then from there we know it's vertical, so it will open up and down. Now keep in mind, we're just kind of doing a rough sketch of this because on the test it's multiple choice. So you're going to have 4 different graphs to look at and just pick the right one. You're not actually going to have to graph it by hand. You'll just have to know that since the y comes first, you should be looking for hyperbolas that open up and down. And you should be able to look at this and know that the a value is 5, the b value is 1 to know how tall and how wide. Okay, number 20. What type of conic is this? An ellipse. Okay, because it has a plus sign in the middle. It almost looks just like the equation of a hyperbola with the exception of that plus sign. Now, under the x squared is a 49. So that means the a value is 7. Under the y squared is a 1. So the b value is 1. Where's the center for this ellipse? 0, 0. Okay, from the center to a side, how big is it? 7 units. So we go 7 units this way and 7 units this way. How tall is it? 1 unit on each side. And then once you've got your 4 points, you can draw in your ellipse. Okay? And I already knew it was going to be wider than it is tall because the number under the x was the bigger number. And a lot bigger, right? So it's a lot wider than it is tall. Okay, number 21. Okay, 21. Now we're moving into Unit 6 material. Rewrite each expression in exponential form. Okay, remember, the cube root of x to x to the 1/3. So the fifth root of 2p is equal to 2p to the 1/5. Okay, but then you got to keep in mind that all of that is raised to the 4th, so that gives you 2p to the 4/5 as the final answer. Now, what if there's a choice that looks like this? Is that the same thing? No. In that scenario, only the p is being raised to the 4/5. Well, is only the p up under the 5th root? No. The 2 and the p are under the 5th root. So the 2 and the p need to be raised to the 4/5. That's why you have to have parentheses. This is not right. Okay, now in number 22, you're just working the opposite way. They gave it to you in radical form. They gave it to you in exponential form. They want you to put it in radical form. So I'm going to draw a radical over the m. What root is it? The 6th root, and then all raised to the 5th power. Okay? All right, number 23. Sketch the graph of each function. Okay, so what you'll do is you'll just get your calculator and graph it. Y equals 3 times 2 raised to the x power minus 2. Graph. That's what it'll look like. Where's the asymptote? Well, look, here's -1, and doesn't it go below that? -2, and look in the equation. It's the boundary line. The function will approach it, but never actually touch it or cross over it. Okay, now once you know where the asymptote is, we're going to do a sketch of this. But to get some points on here, you're going to hit second table. See, it says table up above graph. And look, there's a chart that gives you a lot of points. But I'm going to go up a little because I want to plot some on the negative side of the x-axis and the positive. So -3, -1.6 would be about right here. -2, -1.25 would be left 2 down 1 1/4. -1, -1/2 would be the left 1 down 1/2. 0, 1, that's my y-intercept. 1, 4, and 2, 10. And how is it I got to this page on the calculator? Second table, or second graph, whatever you want to remember it as. And then you have a sketch. But keep in mind, on the exam, you're not going to actually be sketching it by hand like we are now. You're going to look at 4 different choices and pick the right graph. Does that make sense? Okay, next question. Really quickly though, they don't ask for it, but just because I feel like it'll help, let's do the domain and the range of this exponential function. When you hear the word domain, you think of what? X-axis. So this graph, if you go to the left, how far can you go? On the x-axis. Forever. -infinity. How far to the right will this graph go? Forever. All exponential functions have this domain. Every single exponential function will have a domain of all real numbers. Their range is what changes depending on where their asymptote is. This one can never go below -2, right? But it can go up forever. Okay, so with exponential functions, their domain will always be this. It'll always be all real numbers. Their range changes according to where the asymptote is, because doesn't that horizontal asymptote keep you from going either down forever or up forever depending on where it is? Okay, now let's look at number 24. This time they're asking us to sketch the graph of a logarithmic function and then identify its domain and range. So the first thing we need to do is graph it on the calculator. So y equals, now what is the base of this log? 10. So since that is the understood base for a logarithm, you do not have to to use math, alpha, math to pull up log base, you can just simply press this log button right there on the calculator, the one to the left of the 7. And then type the x plus 4 inside the parentheses, and then the plus 2 on the outside. Now, remember with the last problem, it was the very last number in the k place that told you where the asymptote is? Well, with logarithmics, it's the number on the inside of the parentheses. Look at where the asymptote is here. See how it makes a turn right here at -4? That's because of this x plus 4 in the parentheses. So logarithmic functions have a vertical asymptote. Okay, they are inverses of exponential, so everything is opposite. Exponential had a horizontal asymptote, logarithmic have a vertical. With an exponential, you found the asymptote at the end of the equation. With logarithmic, you find it inside the parentheses. Now, how can I find some points to plot? Second graph. Okay, so we have a point at -3, 2, so left 3, up 2. We have a point at -2, 2.3. We have a point at -1, 2.4. Okay, we have one at 0, 2.6. And then the next nice one is all the way over at 6, 3, so we'll just plot it. So it looks something like this. Now, even though your calculator doesn't show it, that went a little above, but oh well. Even though your calculator doesn't show it, the graph will continue to approach the asymptote forever. Okay, so doesn't that mean it's going to go down forever? Okay, so let's look at the domain and range. Remember, with exponentials, it was the domain that was all real numbers. Well, with logarithmic functions, it's the range that's all real numbers. Because you go down forever, and you also go up forever. The domain is affected this time because you have a vertical asymptote. So how far left can you go? -4. How far right can you go? Infinity. Okay, so take a second and try 25 before I go over it. Okay, so log of x minus 1 minus 4. Okay, so they want to know the domain and the range. Now remember, with logarithmic functions, even though it doesn't show it, this continues to approach that asymptote at 1 forever, but it never touches it. So, what is the domain? 1 to infinity. What's the range? Correct, all real numbers. It's always that for logs. Kind of like it was always that for domain with exponentials, but they're inverses of each other. Okay, 26. If you purchase a computer for $1,000 and it depreciates in value every year by 20%, in how many years will the computer be worth $200? Okay, use A equals P times 1 minus R to the T power and logarithms to solve for T. Okay, so we're going to be using this equation. So what goes where? 200 goes where? Correct. To the T, because that's what we're trying to solve for. We don't know T. Well, on the test, you're going to have 4 choices, and can't you just plug in each choice into T until you get 200? Well, without choices, we're forced to solve it using logarithms. This would be the process you would have to do. You would start by dividing by 1,000. That would become 0.2. 1 minus 0.20, we could just write as 0.80, and then to the T power. Now, this is an exponential form. Remember, exponential is y equals b to the x form. We want to rewrite it with logarithms as log base b of y equals x. So when I rewrite it, it'll be log base 0.80 of 0.2 equals t. And then you would just type that in to figure out what t is. Okay, so you would have to do, since the base is 0.80, you would have to do math alpha math. Of 0.80 is the base. And then of 0.2. And so it would take 7.2 years before that that computer was worth $200. Now, like I said, you're really not going to have to know how to do all that on the test because you'll have multiple choices that can be just plugged in for t until you get 200. All right, 27. Expand each logarithm. Right now that logarithm is in condensed form. We want to expand it. Okay, so what is the base of this log? 10, which you really don't have to write, but I just will for the heck of it. So we have log base 10. How many times do I need to write log base 10? Twice. Because we have an x and a y. Okay, now, does it, the parentheses around all of it, mean that all of it is being raised to the 6th power? So technically, isn't it like we have x to the 6th power over y to the 6th power raised to another 6th power? Does everybody see where I'm going with that? So y is really raised to the 36. When you have an exponent raised to another exponent, you multiply. Do you remember when you're expanding a logarithm what you do with the exponents? You bring them to the front. The 6, since it's with the x, it would come down in the front of this one. The 36 would come down here. What sign goes in the middle? It would have only been a plus sign had this been multiplication. When it's division in condensed form, it's subtraction in expanded form. Okay, quickly try 27. See if you can do 20. Okay, it's log base 3. So you would write log base 3 of A and log base 3 of B. What do we do with this 4? Put it in the front, and then 3 goes in the front. What sign goes in the middle? Minus. Okay, number 29. Solve each equation. The first thing you're going to do is divide by -2. Then you have log base 2 of x plus 6 equals what? Guys, negative. Positive for that. Then, this is log form, so you would just rewrite it in exponential form. So 2 is the base, so it would be b to the 4th power equals x plus 6. Okay, you just rewrite it in exponential form. Now you have to calculate 2 to the 4th. What is 2 to the 4th? 2 times 2 times 2 times 2. 16. And then now to solve for x, you subtract 6. But it's already addition over here, and so you get 10. Now, keep in mind, this is also one of those questions where you could just take each of your 4 choices and plug it in. Like, watch what happens when I plug in 10. Okay, so if I type in -2 of log base 2, which means I got to do math, alpha, math to pull up the log base. And then I type in x, which we're saying is 10, plus 6, it equals -8. So that means 10 was right, because when we plugged it in, it made a -8. So you'll just take A, B, C, and D, plug them in until you get the one that equals what it says it equals. Okay, so now let's look at the last problem for today anyway. 30. This is a natural log. Does anybody remember the base of a natural log? Well, that's the base for common log, for log. It's e. Okay, so the first thing I would need to do here is rewrite it as e squared equals 5n plus 2. I rearrange it into exponential form. Then I need to actually evaluate e squared. Okay, e is right here on the calculator, so I have to hit second before I can use it. E squared equals 7.39. Now, what am I going to do to get n by itself? Subtract the 2 from it. And then after I subtract 2, what am I then going to do? Divide by 5, and so the answer is 1.08. Now, that's another problem that couldn't you just take each of your 4 choices and plug in? Like, look, if I type in ln of 5 times n, which we're saying is 1.08, plus 2, I get 2.00148, which is a little bit bigger than 2. And why is that? Why didn't it come out exactly 2? Right, we rounded up to 1.08. See, we rounded up, so it went a little over 2. Had we rounded to like 1.07, or if we just rounded to 1.07 and didn't make that an 8, it probably would have been a little under 2. Okay, but that's close enough to know that you've got the right answer. Okay?
Okay.
No.